Cool. So I want to start out with a little bit of a review. Last time we covered for loops, last two classes, we've covered for loops. And basically, this is sort of the primary looping structure that we're going to be using whenever we can get away with using it. We're going to talk about while loops kind of later on. The main topic for today is going to be concerned with various methods and functions that help us process lists. So I would call this list operations. There's various operations that we can use for lists that'll help us use lists. I know there's a few here. You can kind of use this as a reference if you want. I'm going to show you kind of how I get Python to act as a reference for most of these. You don't have to commit all of these to memory right now, but these are a lot of common tools, some more common than others, but they'll be good to know. But I want to start off with a little bit, like I said, a little bit of a review. For loops, right? So for loops are going to be very useful for helping us work with lists because lists are what's considered an iterable type, which means we can iterate through them. There are a number of other iterable types, and I want to touch on those because I realized our material on for loops doesn't cover all of that, which is okay, but I want to make it clear that it's not just lists or ranges that we'll iterate with. We'll use other things for iteration as well. So let's just really quickly, let's talk about the anatomy of a for loop. We have the for keyword, and then some item. And this is an identifier that we get to name ourselves. This could be called anything you want. Any name that would be valid for a variable is fair game for the identifier there. So for item in iterable, then a colon, and then we have our process. Often we may have if condition, right? Process, finish. Cool. So it's something like that. And this is meant to just be sort of, a skeletal structure that you can kind of look at to give you the parts. Obviously, I don't have an object called iterable, and condition and process are just things that don't exist yet. So I'd have to fill that out. One really common thing that we do with a for loop, I mean, at its core, you can just think about it as this gives you a way to repeat the code that is tabbed in underneath and inside of tabbed in under the for loop. So everything that's tabbed in under this for loop until there's a line that's dedented, that's unindented, that's on the same indentation level as the for loop, will be repeated with this for loop. So that at its core, that's what it does. And we kind of extrapolate that utility into something called the accumulator pattern, which equals right. So we'll usually start an accumulator up here, and the initial starting value will usually be empty-ish. It may have, there are cases where it may have things in it. There are cases where you may start with something that has a lot of things in it and reduce it in size. Sometimes that's called a decrementation pattern rather than an incrementation or an accumulator. So but I think of it as all being under the heading of accumulator. So it all falls under that umbrella term of accumulator. So we have some accumulator, and this is something that we intend to modify usually starting at something empty or 0 and growing its size from there. That's sort of the typical pattern, right? So the accumulator sort of is our process. This is the modify. Well, we could do like accumulator.modify. In the case of a mutable accumulator, or maybe something else in the case of an immutable accumulator. But that's the basic kind of skeletal structure. So some accumulator target for some item in some iterable, and obviously we have an iterable somewhere else. It's coming from some source. The condition is optional, but often you're going to check conditions. That'll be part of your process. You may have no conditions. You may have a dozen conditions. You might have ifs and elifs and else's. Inside here is just whatever arbitrary process that you want to repeat. It's up to you. And then, modify your accumulator appropriately, and then at the end, you're finished. Okay. Cool. So we got a quick question. At this point, the class isn't completely synced up with the syllabus. Oh, sorry. Yeah, I need to go in there and make some edits. I got caught up with a number of things today. It's been a long day, so I will catch up on that and reconcile all that. Cool. Yep. No worries. Yeah, we've there's sort of an intentionality behind this, just so you know. We're intentionally sort of repacing the materials, and we kind of chose to do this rather than like inventing and engineering a new pace for the materials, to just kind of go through the materials at whatever natural rate that works for the group. So and then kind of formalize that in future cohorts. So that's why that is that way. Cool. Just so you all know, that it's not just like random or like a mistake. There's an intentionality behind that. Okay. Cool. So that's a good review of accumulators. Yesterday, somebody asked if I could give an example of a nested accumulator, and I said yes, that's a great idea. Asked me after class, and I went through this example. I'm not going to go through the whole thing again, but I wanted to just touch on this really quick because I realized there were a few things worth mentioning. Less so, I don't as much want to focus on the fact that this is nested, but it reminded me that we didn't, I think all I did was like iterate through ranges and lists of numbers. So what's happening here, I just kind of thought of a random exercise that I could kind of put together, where I have this list of strings. Each string is a word. I constructed this by just copying. I have a couple blocks of text here for if I want to do string processing exercises, just kind of stashed in my notes document so I can access it quick. So I just copied that first paragraph and then quickly turned it into a list. So this is my source, my words list. And what I wanted to do here, let me see if I can, oops, that's 7, I'm still on 6, dang. There we go. What I wanted to do here was iterate through this list, and then in each of these strings collect all the vowels. This is just a random exercise, there's no big, insight in doing this, but it's just, kind of fun playing with accumulator in an accumulator. So I'm iterating through a list of strings. You can see 4 word in the word list. I'll kind of prove what's going on here. Let me comment that out. print word. All right, so you can see there's all my words. Whose woods these are, I think I know, right? So whose woods these are, I think I know. So there's my word. So you can see we're not just limited to iterating through things that give us numbers back, right? Any collection that contains any data type we can iterate through. So you'll see quite a variety of things that you can do with iteration. So in this case, if you look here I initialize an accumulator. I have my loop, and here's the process. But notice the process inside this loop, I initialize an accumulator. I have a loop. I check a condition, and I modify the inner accumulator. Then once this accumulator pattern is finished, I modify the initial accumulator, the outer one. And then I come back, I reset the inner accumulator back to an empty string, and I iterate through the word, right? So the outer loop goes through the word list, and it stores each word in this word variable. So first it starts off as whose, then woods, then these. So word is each word individually, one at a time, in order, left to right, from the list. And then in the inner accumulator, in the inner loop particularly is what I mean, I'm iterating through the word. The word is a string. So it reminded me when I gave this example, I was like, oh, right, I didn't show how iterating through a string works, right? So we could even do something like this. We'll just kind of isolate this inner accumulator, ignore all the rest around it. And let's just say I have word equals trying to think of a big long word. Let's do this. Text. And I'll just grab a little bit of text from here. So here's the text. So I've got a little bit of text. And if I iterate through this text, this is just this little mini paragraph, the stanza from this poem, for character in text. And this works the same. This is that same skeletal structure. To be extra clear about this, it's my choice to call this CH. There's no special reason that I call it CH other than that, to me, when I iterate through a string, it makes sense to me to call the identifier a character because that's what it is. So CH is short for character. I don't like to do CHR or CHAR because there are other languages that I work in where those are keywords, and it just doesn't feel right to me. But I think a lot of people will do CHR or CHAR. I can't remember if one of them is a keyword in Python or not, but sometimes I'll call it C or CH, you know. So just to be clear, there's no special meaning to that. That's just a name that I chose for it. And then text is just the source, and it happens to be a string. So when I iterate through the text, the behavior is that I will get each letter, or excuse me, each character, because some characters aren't letters. We have new line characters. If you see this character that I have highlighted, might not look like a character at all, but that's a new line character, and it instructs the whatever text processor to insert a new line character, meaning go to the next line. But it is still, that new line character is every bit as much a character as O or N or any other character that we would think of as a character in English or in a human language, right? Space is also a character. So we have new lines, which are a white space character, space, and tab, which are also white space characters. So those are what we think of as invisible, quote unquote, invisible characters, but they're each individual characters. So it's going to go through each one of these characters individually and give me a representation of each character under the name ch one at a time. And then in this loop, I'm just saying if that character, if the lowercase version of that character is in this substring, A, E, I, O, U, the reason I'm lowercasing it is, look at this capital I. Well, that capital I is a vowel. That's something I want to capture a signal on. I want this to be considered a vowel, so I say ch.lower, which will lowercase it, and then lowercase I is in this string. If I didn't want to do lower here, you could do A, E, I, O, U, Y, something like that. You just include the capital versions. Or maybe if you didn't care about the capitals, if you really only did care about the lowercase versions, then you'd just do this. But I prefer to do lower. I don't know if I could give a good reason why, but that's what I do. I prefer to do lower there. So the lowercase version of the character, if that is in this, then I know it's a vowel, and I want to increment my vowel. Excuse me, I lost my accumulator there. Vowel word equals this. And then after that's done, then I'll have print vowel word. This is just going to give me a big string with all the vowels. Oops. So it's a bit nonsense right now, but I did want to give this example of how to iterate through a string and what the behavior is. The behavior is that you get it iterates through each character individually. So. Yeah, that's what I recall is CHR. I knew there's a similar function. There's a similar function like a lot of different languages that I've worked in. And some languages call it CHR, some call it CHAR, some have different meanings for those. So, and I always forget in Python if it's CHR or CHAR. So I avoid both of them because since there's other languages that use either one, I'm just like, I'll just call it CH. So, cool. So that's that. All right, we've got a breakout that we didn't get to from last time that I want to touch on. So let's see here. I was just kind of writing some additions to it. So write a function called even sums that sums all the numbers, even numbers in a list. And then I want to do a little challenge before you start. What should the function take as an argument? What should it return? Write a test before you start defining. So write a test to start off with. Make that be your first thing that you do. If you find yourself like getting writer's block on what to do with this, just give yourself a second, see if you can connect with that. If not, then you can skip this part. We'll kind of consider this a stretch goal, but if you do write a test first, go ahead and just paste in your tests in here. Before you get underway in your function, and then you can start writing your function. Cool. And I'm going to put, this says 3 minutes. I'm going to put 5 minutes on the clock for this one since I added a few things to it. Okay, cool. Go ahead and get your answers in. Whatever you've got at this point is okay, just paste it in. You can always work on it later. Okay, so I'll just show how I would approach this. So it says write a function called sumEvens to sum. That will sum all the even numbers in a list. So this was the original statement, right? And it's a little bit, other than giving me the name, it tells me what it does, and it tells me what it does it to. So that's why I wanted to ask, since this is a pretty short and kind of vague topic, I wanted to kind of put it to you to say, well, what do you think, given this statement? It's not explicitly stated that it should take in a list, but if you think about it, what should the function take in an argument? I also saw somebody mention that it should take in a range. And I would say that that is not an incorrect interpretation of this either. We could totally build this to work with a list or a range. So a list or a range as an argument would be sufficient. And probably if you wrote it thinking of one, it'd probably just work for the other one too. And then what should it return? Well, this says write a function called sumEvens, and initially that said 2, but that will sum all the even numbers, right? So if it'll sum all the even numbers, well, if I do the work of summing the even numbers, I probably want that. Probably makes sense to return that, especially since the name of the function is sumEvens, right? So that probably tells me what its output would be, right? Let's write a couple tests. Cool. Let's get into this. Let's say print, and this will take in sumEvens, which will be a list of 3, 7, 5, 6, 9, 8, 1, 4. Okay, so 3, 7, 5, 6, 8, 4, 6 and 4 is 10, 18. So 18. You write a couple tests for this. I'm just going to do one. So I'll say def sumEvens will take in nums, right? I could call it list or whatever, but it was a good point to actually bring up that, yeah, it could be a range. I'll write this with a range too. Why don't we do this? Like range, I'll take in a range, so we could say range. Range 7 to 15. So 8, 10 is 18. 12 is 20, 30. 14 is 44. 44. I think that's what I should get there. So sumEvens will take in some nums. We'll just call it nums. So we'll just print nums just to see what nums is. Well, there's the list that I handed it. And let's be clear about this. You can always, if you run your code and you're not sure what you're seeing, if you have a print in there, you can always label your prints like this. It'll say nums, and that'll tell me that that's nums. So nums is that list, and then nums is range 7 to 15. Cool. If you ever get a little lost, you can always get Python to tell you where you're at with print. Okay. So from here, I'll say ACC. I would call this sum, but sum is a keyword that's built in. We don't want to use that. I'm going to return ACC. So I know this is going to be the thing that I'm going to be collecting the sum into. And remember, that's what I wanted it to return. So I'll say ACC equals 0, return ACC, and I'll say for I and nums. I'll say for num and nums. For num and nums. If num mod if num mod 2 equals 0, so if I get the remainder of dividing num over 2, and that remainder is 0, and I can get the remainder of a division operation with the percent symbol, which is called modulo. It's a little convoluted there, but that percent symbol is called modulo, and you can think about it as the remainder operator. So that modulo operator will give me the remainder of num over 2. And if that remainder is 0, then I know num is evenly divisible by 2. If it's evenly divisible by 2, it's an even number. So I'll say ACC plus gets num, like that. I'll add the value of num into ACC, which starts at 0 right there. And then once I'm done, I'll just return. So I should get 18 and 44, and that's what I get. Perfect. Any questions? I'll give it a second here. Cool. I'm going to assume we're good. I'm going to forego the overview today because the sort of intro examples here and the breakout took a little time. And I think, I don't want to just harp on the overview if you already know it. So maybe we'll do it next week, the beginning of class. So let's change gears here a little bit. Oops, sorry, it looks like we do have a question. I was trying to do this if no evens. Also is trying to include negative numbers. Ah, interesting. Yeah, this could be, we could like think of like wider constraints for this, but I did just want to keep this one maybe a little, on the simple side. So yeah, cool. Yeah. All right. So let's change gears and start talking about list operations, methods and operations. So methods, some of you may be familiar with what a method is. A method is very much like a function. It's a formal abstraction. You've heard me talk about abstraction. Okay, just do the overview really quick. Types. Iteration. Okay, cool. Okay, yep. Types, abstractions, control flow, iteration. So variables, functions. This is how that would actually all fit together. Classes or methods are sort of a subset of classes. We're not, there's a lecture that I have prepared that we might not get to this go around that goes over classes. I might do it instead, since we're repasting our material, we might drop this one and I might do it instead in like a study hall or something. What we're focusing on is really being able to write variables and functions, but methods, essentially we can think about methods as a part of, or we can think about methods as very similar to functions. And it'll become clear what I mean by that. We're not going to talk about how to write our own methods, but there are a lot of built-in methods that are really useful to know, and I've already shown you a few of them. And so we're not really introducing a new concept, a concept you haven't seen before. We're just kind of going to formalize a concept that you have seen before. I don't need to go over control flow. To be clear, we're going to be spending our time here today, lists. So that's where today is going to be spent. And this is the first deep dive. You've heard me say before, like, I think I've talked about this. You can kind of learn the details of, how to apply. Why would you use an abstraction? How to use correctly, put an abstraction together syntactically, semantically. Same thing with control flow and iteration. Why use those things, and then how do you correctly construct the syntax and catch errors and all that. And then the rest of your time, most of your time learning a language, learning Python, it's probably going to be after you kind of become comfortable with these problem solving ideas, is going to be involved in like learning operations and how to apply the different data types, right? So this is our first sort of deep dive into that. The other types we've covered aren't kind of aren't as complicated. Strings are sort of subtly more complicated than they may seem. But lists are our first sort of complex type. They're mutable and they have a number of operations that we can use for them. Okay, so that's where today is, just if you want to know how everything fits together. So that's methods are just, you can think about a method as a function that is a built-in property to a given data type. If you know what classes are, if you have experience with an object-oriented language, or if you know a little bit about object-oriented programming, Python's data structures, Python's data types are classes, they are objects, and there are lots of other, third-party objects and objects from other libraries that are essentially their own data types, such as NumPy arrays and pandas data frames, etc. So things like that. If you're not familiar with classes or object-oriented programming, don't worry about it. Just know that methods are, it's like a function that is a built-in property of a data type. That's how you can think about a method. When we say operations here, that's just a generic term for, maybe it comes in the form of a method, maybe it comes in the form of a function, maybe it comes in the form of an operator. There's slicing, there's, we can loop through a list, right? So when we talk about a type operation, we just it's just something we could do with that type, and so it's sort of the broadest subset of a thing that we could do with that type, right? So that being said, here's a good list of things, and we'll just go down this list. I'm going to go down each one of these and talk about them. So before I get too far into this, this is going to talk about a number of things, some of which are functions, some of which are methods. Some of these will help us, or functions that will help us with iteration and things like that. I want to show you something though. So this works for the methods. So I'm in my terminal here. If you're in Replit, this is just, you can do the same thing in the Replit terminal. You could also do it here, like print dir. You just do this in a print in your code and then just run your code and it'll do the same thing. But let's just look at this really quick. So I'm going to call a function called dir, dir. It's a built-in function built into Python. And dir is really helpful for seeing what methods a given function, or excuse me, a given data type may have. So I'll say dir, and then I'll just pass it the type that I want to know more about, right? Anything that evaluates to that type, right? So an empty list will suffice. Coincidentally, dir returns a list of all the methods available for that type. Sorry, I just got kind of a beeping noise. I'm wondering if somebody has their audio on. Or actually, I wonder if my headphones are running out of batteries. 1 second. Check. My headphones were running out of batteries. Sorry about that. False alarm. Okay, they'll be good now. Can everybody still hear me okay? Okay, cool. Okay, so this is going to show me a list of all of the methods, all of the built-in, think about it like all of the functions that are built into this type. Since if a function is built into a data type, it's called a method. You'll notice these ones at the beginning that start and end with these double underscores. So they're called dunder methods. There's 2 underscores at the beginning and 2 underscores at the end. For now, I'm going to ask you to pretend like these aren't here. We're not going to be getting into what these are. If you want to learn more about dunder methods, it's kind of out of the scope of what we intend to teach here in Premium Prep. I won't discourage you from going and learning about them. If they seem confusing, you will learn about them someday, I promise you. But right now, I just want you to focus on the regular named methods, because these are the ones we're going to really be using anyways. So I'm just going to copy those. And this is going to give me all the methods for lists, right? And if I look at this, this is most of what we have in here, right? So we've got append, the append method, where's extend, there's a remove, there's a few other ways to remove. Pop is also related to remove, right? So this is going to give me most of what's here, most of the methods. I think I'll just reverse that real quick. Cool. So I'll try to keep it clear what's a method and what's a function and all of that, and how everything kind of fits together. So, so these are all the methods, obviously. One thing I want you to keep an eye out for, in general, this applies to this lesson and in general with any sort of complex type in Python. You can think about, okay, how do I learn how to use lists? Or how do I learn how to use dictionaries or sets? You could even apply this to some extent to tuples and strings as well. So anything that you can think of as kind of a collection. There's an acronym that's useful. I find it to be a good basis to start from as a like what things do I need to know in order to like start being able to work with this. Now, this isn't quite comprehensive, but it's definitely a good one. So CRUD, and I actually lifted this concept from my training as a full stack developer. CRUD stands for create, read, update, delete. It comes from a full stack development concept, building a CRUD app, which is sort of thought of as like a simple but complete app where you can create elements in a database, read elements from a database, update elements in a database, and delete elements in that database. That database could be a file, it could be a database, it could, in this case, it's a list, right? Which is not really a good analogy to an entire database, but it has that somewhat of a similarity in terms of it just being a collection of information. Yeah, CRUD and databases, bingo, yeah, you got it. So I noticed that this is a helpful place to start, right? It doesn't give you, excuse me, it doesn't give you everything you need to know, but it gives you sort of the foundation, right? So create, read, update, delete. So we can ask this question of lists. How can I create a list? How can I read a list? How can I update a list? And how can I delete a list? And then there's another dimension from this, which is, and there are also several ways that you can interpret each of those. Does deleting just mean clearing out all the elements, or does it mean actually literally removing the entire list from your program's memory, right? There's a way to do both of those. So some of these can have multiple valid answers. So it's just meant as a good starting place. Be a little creative, a little open-minded about, what the answers to these could be. That there could be multiple answers, and that there's a bit of subjectivity here. So there's another dimension of this, which is how could I create a new element in a list, not just the whole list, but a new element in the list? How can I read a specific element from the list? How can I update a specific element in the list? So I locate an element and change its value. And I could also change its value. I could change its value to something completely different, or I could change its value to something that is takes into consideration its current value, right? So we can modify it according to its current value. I could increment it or decrement it, or do something like that. And then how can I delete or remove a given element in a list, right? So we could apply CRUD to understanding lists, create, read, update, delete the whole list, or create, read, update, delete just a given element. So, and with each of those, there could be kind of multiple ways of reading each of those. There's some things in here that don't fit in with CRUD that are still really important. Len gives me the length. Sum gives me the sum of a list of numbers. Sorting and reversing change the order. And I guess it's kind of an update, right, of sorts. Min and max tell me the minimum and the maximum count, lets me count a given element. Any and all are sort of Boolean operations. We'll get into those. So some of these don't quite fit into CRUD, and they're still really important to know. But yeah, anytime you're learning a new collection type in any language, start with CRUD, and that'll give you sort of the basic foundation. Then you can go learn, okay, what are all the other things I need to know about this? But that's a good place to start. Okay, so that being said, let's just take these one by one and knock them out. So appending. So first of all, let's think about just how we can create an empty list. I'm just going to call my list variable lst. I can't call it list because list is a built-in function. It's also the type identifier name for a list, right? So it's a word that already has a use that's built into Python. Again, Python will allow me to call something list, but I lose the type identifier. You lose access to the type identifier if I do that, so I don't want to do that. So we'll call it lst, and I'm just going to initialize a list. This is a new empty list. If I wanted my list to have stuff in it, I could have stuff in it, right? So new empty list. So let's say I want to add something to that list. So that's, this is create the whole list. and append will help me create a new value in the list. So let's say create new value with append. I could say list dot append hello, and let's just print list. There we go. Oops. So you can see we have an empty list, and then I appended hello, and then we have list with hello in it, right? If I append something else, if I do hello world, then we're going to get hello world. Cool. Extending, so append, we looked at the append method. Extending, at some point you will encounter a situation where you'll get comfortable with append. Honestly, I use append all the time. You're going to use append like all the time. And you're going to think to yourself someday, you're going to be like, oh, I need to add like 3 things into my list. So I'll just, why run this? Why run append twice when I could just do hello world like this? Let's try this. That's going to give me an error, right? We can't do that. Let's say copy. So this, can't do this one. That one gives me an error. Anytime you get an error, as a place to start, one thing you can do is just comment out the line that gave you the error, if it's and then copy the error on the same line or next to it, just comment them out and say, okay, so this line would give me this error, right? That'll help you learn your errors. Okay, so if append takes exactly 1 argument, 2 are given. So we can't do this because we can't pass multiple things to append. If we want to append multiple things, we can either run append multiple times, we could run it once in an accumulator or something, or in a loop, repeat it however many times. But sometimes it's useful to be able to just append multiple things kind of quicker and easier. I'm going to do this real quick. Okay, let's look at extend. Extend will help us with this. So extend is going to, let's start this list. So we'll say, we'll call this list 1. And I'll list 1 dot extend. And I can extend this list with another list. So I could say, right? And let's print list 1 again. Okay, see what that's going to give us. Okay, so this gives us the same thing, right? So this is useful if I have 2 lists and I want to combine the contents, say, of list 2. Like that. Oops. Didn't pass anything to extend there. I could extend list 1 by the value of list 2, and then yeah. So let's say I had hello there. We'll do this. I'm trying to think of a good way that makes this nice and clear. So we've got hello there in list 1. And then list 2 is world. And then if I extend list 1, oh, dang. Okay, 3rd time's a charm. that's kind of clear. Now we're extending it by two things, right? Hello, and then their world, and then we're extending it by their world, and we get hello, their world. Okay. We got a couple questions here. Could you append a variable and string together? A variable and a string. So, when you say a variable, so I think of a variable as just a something that points at a value, right? So LST is a variable. It points at an empty list. I could, we could do, let's say, stir1 equals hello. I'm not exactly sure what your question is, but you can append anything that evaluates to a value, right? Hello evaluates to it's a string literal, and it evaluates literally to hello. That's why we call it a literal, because it evaluates to literally what you see. Stir1 is not a literal, it's a variable, but it evaluates to hello. It evaluates to that string. So it's anything that will evaluate to something. I could append, like a squared plus b squared. I want to do Pythagorean Theorem. That'll give me c squared. So if I say a is 10, b is 19, that'll give me c squared in that one. 461. Of course, we do the square root of that. Right, so it's just any expression. You can put any expression in here that would express a value. Of course, you can append any values, so that'll give me the value of c. If I wanted to, like this list now contains hello world and the length of the hypotenuse of a triangle with sides 10 and 19 of a right triangle. So that's what this weird list contains. But yeah, you could do that. You can combine variables in here. It's just any valid expression can go in that append. Does that make sense? Hoping that makes sense. Let me know if that was helpful or if you need more clarification. Okay, seems like you're good. A guide to recognizing your errors. A guide to recognizing your errors. I should put something together by that title because yeah, learning to recognize and get good at handling and errors and administering errors quickly is a really good skill. I mean, it's a very central skill in getting competent and getting good at programming. I'm just going to say this, you're probably never going to stop getting errors, so the sooner you accept that and the sooner you just start getting good at dealing with the errors that you get, the quicker you'll become a better programmer. Need to learn those hotkeys? Yeah. Can you only use extend to add lists to other lists? Yes. Yes, you sure can. But you can think about it as next time you try to append multiple things and you get that error, where's that error? Append takes exactly one argument, but two were given. You say, oh, I'll just extend, and I'll just write this as extend, and I'll toss this in square brackets, and no one will be any the wiser or something, I don't know. So we can extend one list by another list. So I would let's do this. Let's say, crud. Let's do, this is getting a bit out of hand. That's okay. This is creating a new value. Like that, creating a new value. and we'll say extending, create several new values. Notice in any case, it's going to place the values on the right-hand side of the list, and that matters. Order is preserved in lists, so it's useful to know when you're adding something in, where does it go? Does it go to the beginning? Does it go to the end? If it's not important where it goes, then the default assumption is that it goes in the end. So append puts something on the end, extend puts multiple things on the end. That's one way of looking at it. Another way of looking at it is it expands the list that you're calling it on by the list that you're passing to extend. It alters the list that extend is called on by adding in the values of the list that you passed in. It does not alter the list that you passed in. So it occurs to me, let's print out list 2 again here, right? So notice list 2 contains their world, and when I run extend, notice how the value, I've got to label all these. It's the only right thing to do. It's the only right thing to do. LST1, and this one is going to be 2, 2. Okay. I'm sitting here like trying to talk it all out. I'm like, nope, I just got to label them. Okay. So the value of list 1 starts off as a list with hello. Value of list 2 starts off as a list with there and world. We run extend, then the value of list 1 has hello, there, world. We extend list 1 by list 2. So list 1 changed. List 2 did not change. So, make sure you're changing the list you want to be changing. Okay, cool. We're already at halftime. I swear these lectures go faster and faster every time. Let's take a short break. Let's just reconvene at 10 after the hour. Somebody's asking, I'll take this question. Feel free to just start your break. The person who just put in a question, I'll answer your question right now. Is extend isn't limited to just lists. You can just extend using other types as well. Extend is limited to only lists. So what I mean by that, extend is a method for the list data type. Most methods show up for only one data type. There are some methods that have the same name and essentially the same behavior that show up for multiple different data types. Like count, there's a count method for lists, and there's a count method for tuples. Once we get into talking about tuples, I'll give an example of this, and they function exactly the same. They have the same name, but extend is exclusive to lists. So we call it on a list, which is list 1 in the case that I'm demonstrating here, and we pass it a list. So the contents of the list we're calling it on, and the contents of the list we're passing extend don't have to be lists. Those contents can be any data type. So a list of arbitrary type dot extend by some other list of some other arbitrary type. But the method is local to lists and lists only, and its input is, I believe, only a list. It might be able to take in tuples, although I don't know that I've ever used it that way. I'm not sure that that's that important. But essentially, you could think about it as only lists in both cases. How does using differ plus, are you saying how does using plus differ for string appends versus extend? Okay, so for concatenation, plus differ. Okay, cool. That's what I was thinking. Concatenation. concatenation, it has to do with mutability. Strings are an immutable data type. We can't actually ever modify a string. We can get what we call a transform of a string, which is a different string that's based on some other string. It's like a different version of a string, but in memory, it's a different string. The analogy is if I had a string and I concatenated something onto it, what I'm doing is I'm creating a new string and saving that new string in the old variable, right? So I'm updating the variable by pointing the variable at new different strings, and it certainly feels like an append. It functions a lot like an append. The difference is that every time that concatenation happens, the variable points at a different object, points at a different version of that string. Whereas with lists, the variables, if we do list.append, notice there's no list equals some new version of the list. We're not reassigning the variable. We're calling a method on a variable that has a list in it to modify that list, which means the variable does not change what it's pointing at. It's just that the value that it's pointing at changes, and it's a subtle but very important distinction. If the value changes and the variable points at an object with the same ID, then it's been mutated. If the ID changed, or the value changed and the ID changed, then it's an immutable operation where we pointed the variable name to a different object. So a bit different there. Cool. I know it's a weird one. And please help. List extend. Oh, hey, yeah, okay. So I guess you can pass a string to extend, and it'll that's a good example. Somebody gave an example. I can't say people's names because this is being recorded. Yeah, somebody gave an example of this list extend, and then they're passing a quote, a string of help, and it looks like the behaviors that it places each character individually into that list. Oh, okay, so there's a follow-up to a previous question that I answered. The question is, can you add multiple strings to a list? If you use extend, you can add multiple strings. Yeah, that's the example that I'm giving here, right? So we have a list with a string in it, with one string in it, could have multiple strings. And then we have list 2 with multiple strings in it, and then we run extend. So essentially what extend is doing is, you could think about it like it's like an append. It's like 2 appends or whatever. I'm hoping that's answering your question. Cool. And a lot of good activity in here. Unfortunately, the break time has elapsed very quickly. Oh, I see what you mean. You're asking if you can pass in the strings, like multiple objects, into extend rather than putting those objects in a list. I'm sorry, I didn't glean that. Yeah, the answer is no. I believe we'll get, let's see, I think we'll get the same error. Let's try that actually. I can't believe that I didn't glean that that's what you were asking. Apologies. Okay, let's just try this. I do want to see what error this gives me. Extend takes exactly once. Yeah, so this is exactly the same error as we get for append. So that's what will work. By the way, you might be wondering, you might look at this and say, okay, so I can't append another list to a list. You can actually append a list to another list, but you get a whole different set of behavior here. Let's do this real quick. Oops, dang it. Okay, so let's look at a different version of append. Right, so if I try to append this list, it's not going to append each element in the list. It's not going to extend the list by all the elements. It's going to append the whole list, right? So notice I have a list with hello and then another list, and that list has there and world in it. So different behavior. Like same code, but I changed append to extend, and I get a slightly different behavior. Okay, cool. Removing. So removing. Let's do remove and pop together, because these kind of have to do with delete. So we're kind of going out of order with CRUD, but there is a, let's see, it is remove and pop indexed into that. Okay. Let's do this. Remove / pop. So these have a little bit of a different behavior, but in either case, I would file them under delete. So let's say I've got, we'll just take this list. Hello there world. And let's say I want to remove this there because it's a little out of place. So I just wanted to say hello world. So I could say, first of all, let's do a before lst. I should just start preemptively labeling these just so we're clear. This is going to be lst. Okay. And then we'll say list.remove. There. Oh, I was like, wait, it didn't work. I forgot to print it again. Okay, so before list before after. So what we can extrapolate here is if there's a value, and here let's experiment with this. So if there's a value that I want to remove, I can say list.remove if I know the value that I want to remove, and it will remove the first occurrence of value passed. That's what it does. So if I know the value that I want to remove, the element, I can use remove. What if I don't know the element and I just know the index? So what if it's like I don't really know what the element is at the 0, 1, 2 at the second index, which we'll remove world here. But whatever's there, I just want to remove it. I can say list.pop. And then I give pop an index. If I don't, I can choose not to give pop anything. If I don't give it anything, it'll actually remove the last element. So let's try this out. So this will say, so before we have hello there world there, and then after we have hello there world, because it's going to assume that I wanted to remove index at -1. But let's say I want to remove index 2 or remove world, and we get hello there. Right, so this is going to give me, so one thing I want you to notice, the methods that we've looked at, append, extend, remove, pop, they all are what we consider mutable methods. When you hear me talk about input, process, output, I encourage you to go through, and I'm not doing that for each of these because I want to just keep moving at a consistent pace so we can get through as much as possible. But this is why I have process in here. That alteration to the list is not an output. And in fact, I want to be clear here. First, before I say this, it might be kind of clear from the context of what I'm saying right now, but what does your intuition tell you about this code? So we're back up to append here, right? Empty list, we'll print the list. We have a stir1. Let's just comment all of this out for now. So we have stir1, hello, list.append stir1, print, we'll print list.append. So what is the value of list.append stir1? Or, I mean, let's make this even clearer. We'll take that abstraction away. Print list append stir1. What do you think the value of that is? And what I want you to pay attention to here is you're not trying to get this correct. Pay attention to what your intuition tells you. What does your intuition tell you? What assumption are you prone to make here? Because our brain makes these kinds of assumptions, and it's not bad. It's just useful to keep track of when it does it and what they are when you can. You go ahead and put it in Slack. What's your assumption about what's going to print out here on line 89? It'll print hello or hello with hello in a list, right? I mean, that's what when we did this append, and then we printed list, that's what we got, right? We got this hello. Oh, I'm doing it twice, that's why. So we print an empty list, and then we call append, and it prints hello. But if I actually literally print the append operation, none, right? So it's important to keep this straight because this tends to be a feature of mutable operations. The point of performing a mutable operation isn't to get a value returned. They're not useful for the values that they return because we think about them, even though none is a valid value and technically it's being returned, in practical terms, we think about them as not having a return. So append doesn't return anything, or we could say it returns none. So it's kind of weird, right? Because why would I say that? Obviously, it modified the list. Shouldn't that be a return? So a modification is a different idea from a return. We keep those ideas very nice and distinct, right? So when we change the value of something, we think about that's a mutation. We've mutated the value. When I pass in an object into a function and the function returns a value, there's probably not a mutation happening. It's probably just performing an operation and giving me a value back. Now, there might be mutable operations that happen inside the function, but that function, for when I'm using it, is a black box. I don't really care about how it does it, just so long as I have faith that it's doing it well enough for what I need to do. That's all that really matters. Okay, so this is an important idea, right? These mutable operations that we've looked at all return none, right? I could do the same example for extend returns none, and remove returns none, with the exception of pop. pop is a really weird method because it's a mutable method because I call it on a list, I pass it an index, and it removes the element at that index, but it also returns the element. So this is kind of cool if you want to process a list and you want to think about it like, I've got these objects and I want to take something out of the list at a given index, and I don't know what that thing is yet, but I know what the index that I want to pull from, so I'm going to pop that out of the list and pull it out of the list and get it returned. So what we can do with pop, if I print out pop, you're going to see it's going to return world. All right, so there's our pop world. Pop world. Okay. So this is an odd behavior, but it's wildly useful. So I'll call this res like this, and then let's do like that. So there's res. The result is world, and that's the result of what pop gives me back. So pop is the only exception of this rule that I can think of off the top of my head, where it's both a mutable method. It causes a change into the object where we call it on, the list, and it also returns a value. And that's important to remember about pop. So as you're going and learning different functions and methods, all Python functions, any Python function will not mutate its inputs. So we pass in arguments, and we can be assured that the function will not mutate the arguments. Depending on the data type, many methods will cause a change into the object it's being called on, but again, never the inputs, right? So the inputs are always safe. The inputs into a method or a function will never be altered. So it's important to keep track when you're learning methods, which methods cause a mutation and which methods return something. And in every case that I know of, it's either or except for pop. And it's important to remember this about pop specifically, that it's an exception to that rule. Okay, cool. So it looks like we had a bunch of Slack activity here. I want to get caught up. Intuition. Append doesn't return anything except for pop method. Yeah, okay. With the exception of pop because it's also a mutable method. You can write functions that alter the inputs, but it's convention not to write. Does something about scope limit you? So this is actually a good point. We're kind of getting into the weeds a little bit with this, but so I'll wrap this particular one up here regarding functions being able to alter their inputs. So functions, any built-in function, any function that is built into Python will not alter its inputs. Any function that you write, if you pass in a list or another mutable object, a mutable object is an object that has mutable operations. You know, append, extend, remove, pop for lists, those are all mutable operations. So if you have an object that has any mutable methods, or there's some other operations that end up causing a mutation with slicing and indexing, some things like that. But basically, if it has any mutable methods, then it's a mutable object. So if you pass in, if you write a function that takes a mutable object as an argument, Python will not stop you from mutating that input into that function. There's nothing stopping you from doing that. Well, I'm going to give an example of this, and we'll kind of give an example when we look at copy. Oh, copy's not in here, is it? Oh, that's really surprising. Okay, well, we'll get to that later then. Python will allow you to do that. You're allowed to write a function that takes a mutable object and then mutate the object, and that mutation will propagate outside of that function. This is considered an anti-pattern. It's pretty much universally considered a bad practice. If you do it and you show it to me, I will correct you. I will say, don't do that. If you say, yeah, but I'm going to say, that's fine, but just don't do that. There might seem like there's a good reason to do that. I have thought about this particular thing a lot, and I've never actually been able to justify it. So if you're interested in a philosophical discussion about that with me, I'd be happy to dive into those weeds in study hall tomorrow. If you want to stop by study hall and pick my brains about mutation, we can have some fun with that. Cool. Yeah, let's get into some more of these operations here. Let's do another one, len. So len is a function. We're kind of out of the sphere of CRUD with len. Len and sum, we'll do len and sum together. So these are functions that take in lists as inputs. So list equals, len is short for length. Anybody want to guess the length of this list? I mean, ask your intuition. I mean, I know I've given examples of len before, but you know, this is another kind of formal reaffirmation of what that is. Yeah, so it's 3 because we got 3 elements in here, right? So it just reflects the number of elements. Yeah, and then sum. Sums a list of numbers, right? These could be ints or floats. They could be positive or negative, but it just sums them together. That's all it does. If I try to put a string in here, you know, we can, lists in Python are, what do they call it? Heterogeneous, meaning we can mix and match types. They take arbitrary data types, we can mix and match them. I could have numbers and strings, other lists, whatever. So if I add this hello, the length increases to 4, length is fine. Sum, not so much, can't do it. Or let's do this. So here I'm just recording that error. Okay. So here's a list of numbers. I can get the length of it. I can get the sum of it. If I try to sum something with something that isn't, you know, isn't a number, it's gonna get weird. So unsupported operand for types plus between int and string. You know, I don't know if this has ever occurred to me, but I wonder if I can concatenate a bunch of strings together with sum. Let's try that out. Let's say hello, then space, then world. Like that. Let's see what that's gonna do. Aha, okay, so even if there's only strings, it's still gonna happen. Oops. There we go. So both of these will give me the same error. Okay. So when you're using sum, it's got the sum takes in as its argument a list of numeric values. It can actually take in a tuple of numeric values or a generator or another iterable that gives numeric values, but usually it's a list. Okay, sort and reverse versus sorted and reversed. Okay. Let's do all 4 of these together. So 2 of these are methods, 2 of these are mutable methods, and 2 of these are functions. So we could think about these, I guess, as updates, kind of. Let's call this kind of. I'm going to put asterisk next to it because it's sort of an update of the list. Let's say I've got a list. Let's try sort. So I've got a list. We'll print the list. And you know what? I should be doing these labeled lists. Okay. Dang it, I've got a before and after. I should actually do the whole thing. All right. So before, after, okay. Okay, so I've got my before and after lists. There is no before and after anything yet, but so we'll say list dot sort. Sort. Now we've got the parentheses for sort there, but we don't need to pass anything into it. We don't pass any arguments into sort. So if I look at this, and I'm just going to print off sort just to kind of drive the point home. I mean, you know, ask your intuition again. What is this line 158? This line right here, what's that going to give you? You probably already know because I, you know, kind of keep harping on this. That's going to give you none, right? So it'll still perform the sorting operation. It just doesn't return anything. And if we try to print it, we're going to get none. So, or it returns none. So I have this list with the elements that are not in sorted form. I call sort, and then the list is sorted. Okay. So let's look at this. So there's a function called sorted, S-O-R-T-E-D, sorted. So before, here's our list. Then I print the sorted list. Notice it prints out the sorted list, right? So sorted returns the sorted list. So this is a good example of mutation versus return, right? Does it perform some process, some mutable process, or does it cause a, or does it return a value, right? This is a great juxtaposition of that concept, right? Here, sort returns none but causes a mutation. Sorted does not cause a mutation. You can see the before and after lists are exactly the same. So no mutation was caused to the list, but it returned that value. If you want to use, there's some redundancy here. If you want to pick a tool, just use sorted. If you have a list and you want to sort it, say list equals sorted list. And this is a whole lot like a mutation, right? This is going to be very similar to a mutation. It's going to kind of feel like a mutation, even though it's kind of a fake mutation. Let's try this. Dang it. Let's do copy. And we'll print the ID. And maybe you'll see another cut of what's going on here. So we'll print the ID of the list, right? So if we look here, right, the ending few numbers, oh, well, that's kind of funny. They're actually pretty similar. Let's try this again. Let's get different numbers. Okay, these are different. So we look here, this one ends in 7648. This one ends in 1216. That tells me they're different objects. So sorted performs a transform and returns a different object, okay? So there is some duplication of memory with sorted. I find that it's sort of an easier tool to get up and running with. It's nice to be able to just return the value and use sorted list in place where you want the sorted list. And it's, if you want sort of a mutable behavior, you can always reassign the variable to the new sorted version. So it's something that's helpful. With a function, do you have arguments and methods? You use variables. So variables, a variable just holds, I would say, I would think of a variable as having an anatomy that looks like some identifier name, which is just some name that you give it. It could be foo or bar or poodle or LST, right? That's just some name. So you have the name and then the equals operator, which is the assignment operator. So name gets and then value. That's what a variable is, and it's a distinct idea from functions or methods. So functions take in arguments. Those arguments have to evaluate to some value. We could capture a value in a variable and then pass the variable into the function as an argument. The variable will evaluate to its value. We pass the value to the function. The same could be said about passing a value directly or via a variable into a method. Same deal. So methods have a what's called, if there's something different that we could say like a method has that a function doesn't have in terms of how it looks when we're using it, we could say methods have a calling object. So if we go to, let's go to, and this might be actually, as I say this, I think maybe this is what you're talking about, right? So this variable LST is the calling object. This list is the object that's calling pop. So that's what a method has. So that's how I would break all that up. I wouldn't want to conflate the idea of a variable because a variable is just a name that holds a value or points to a value. Methods have an object that calls them, that we call them from, and then they can also take arguments just like a function would. The calling is what I'm having trouble with. The calling object, you could think about it like the object that's invoking it, the list that's invoking it, the data type that's invoking it. Another word for calling object could be invoking data type. the data type that's responsible for, or the instance of that data type. That's what I mean by object. The instance of list. This particular instance of list is calling pop. So yeah, it's a bit of a weird one, but you know, if it helps to think about like, okay, I have a variable and then I can, depending on the type that variable evaluates to, I can call a method on that. You could sort of get by on that analogy, like thinking of it as methods have a variable that calls them. It's a little bit of incorrect nomenclature, but if it helps you think about it, I'd say that's not a bad paradigm to start with. A calling variable, yeah. Cool. I'm trying to just kind of skim through, make sure I get some of the questions. In what case would I want to use sort versus sorted? There are cases, I would say, if you don't know, sorry, this is a bit of a reductive answer, but if you don't know, if you can't think of a reason to use one over the other, just use sorted. Since these are redundant tools, I like to just teach sorted because it's like, you don't really need both. You can get by on one, and sorted is kind of easier to learn and start off with, I think. The start of the longer answer is, since sorted returns a different object, there is some memory duplication. If you were working with something with like, if you're working with a list with like maybe millions of records, you might want to think twice about like arbitrarily just duplicating that list in size in your program's memory. But in reality, 1,000,000 records is a very meaningful amount of information in terms of being able to do useful computations, but it really isn't that much RAM. It's, like my computer, your computers probably have like 8 or 16 gigabytes of RAM. Mine has 40. I don't really care if I need to duplicate another 1,000,000 records. Meh. I got the RAM to handle it. A decently spec'd computer will. So a lot of times, even a large memory duplication, even if it's noticeable, it's still going to work. It's still going to be fine. So, the worst case scenario with sorted is that in some cases it might be a little slower. The better case is that if you're learning, you're picking up tools, I think sorted is an easier and more versatile tool to get started with. You will develop the understanding someday and you'll know when to use each one. Okay, let's get into reverse. I said I'd do these all together, but I'll keep these separate actually. Keep sorted separate from reverse. So we've got the reverse method, and this is sort of a similar thing. We've got a reverse method and we've got a reverse reversed function. So regarding this follow-up on the sort method, I do want to talk about this. I have to keep myself constrained to going over this material because I want to get through as much of it as possible. If you're willing to stay on a little after class, please remind me if you ask this question again, and I'll go over some examples. I'd be happy to go over some examples if you don't mind waiting till after class. If you can't stay after class, just DM me and we'll sync up about it later. Cool. Can I continue to record after class? I guess I could. I kind of like to turn it off, and that way I can kind of interact with people. People can turn their mics on, and I can say people's names, and it's easier to communicate. But yeah, I think it's okay. They think it's fine if we don't do that. I'll record after class, but I'll just remind people that you can't turn your mic on if you do that. Otherwise, I'll have to edit, which is kind of a pain. Okay. Okay, cool. Let's see here. LST. Okay, I got to get into reverse here. The reverse function. So, R-E-V-E-R-S-E. Reverse. Same deal. So the reverse method, I said function, but reverse method returns none, right? But it causes a mutation, right? Now, this mutation isn't so bad because if you wanted to get back to the original list, well, you can always run reverse again, and that'll get you back to the original list. If you just reverse the reverse, you're back to the original. It's not uncommon that you'll want to, like, maybe you want to iterate through a list, but you don't want to iterate from left to right. You want to iterate from right to left. Or, I don't know, there's various operations where you have a collection and you just want to get the reverse version of it. So various utility in this. Yeah. But just know that this is a mutable method. It'll cause a change in the list. But it's a very easy change to undo. Whereas, if you sort a list and then the original order was meaningful in some way, and you called the sort method on the list, well, you better have copied that list and saved the original version somewhere else. Otherwise, it's just gone, right? Like the original version is gone. You can't unsort a list. There might be one way to sort a list, but there's, however many permutations of every possible ordering of every object in the list, ways to unsort the list. So unsorting essentially isn't possible. But unreversing is, So that's that. Let's do this. Now you might say, okay, well, I know what to expect for this one. Okay, let's just look at this. Oh, I was like, wait, what? Nope. There we go. Reversed is a function, not a method. Okay. So, look at this. This does not return a reversed version of the list. It returns a list reverse iterator object. List reverse iterator object. So imagine okay, I'm going to use my million records example again. Imagine you have a giant list with 10 million records in it, and you want to iterate through it backwards, right to left. You could copy it and then get a reverse version of it. Now you have 20 million records, just so you could iterate from right to left instead of left to right. Probably don't want to do that. Another one is you could call the reverse method on it. You have it's a simple operation to reverse a list, but if there's a lot to do, it's a lot of a very simple task can still add up, right? Like, taking the last object and then making it first, and then the last object and then making it the second one, and then the last object and making it the third one, and then like going through there. It's a really simple operation, but if there's a whole lot to do, that computation can still add up. So calling the reverse method can still, even though it doesn't duplicate the memory, it can still be a computational overhead potentially. Maybe not a huge one, but still potentially. So it's easy to build what's called an iterator object, which is essentially, it just says, it's basically a function that says, I will tell you what the next item is in this collection, and I'm just going to do it backwards. I'm just going to iterate through this backwards. So it's essentially a plan, or like a very simple algorithm that just says, give me the last element, and then the next time give me the next to last element, then the next time third to last element, then the next time fourth to last, fifth to last, sixth to last, seventh to last. So it's essentially a very simple algorithm. There's no huge computational overhead. There's no memory overhead. So it's a very efficient thing. And it's useful for if you want to write a for loop to iterate backwards through a list. If you do want to turn this into a list, let's see if I can, okay. If you do want to turn this into a list, okay. I typed it right that time, yay. Okay, so in this case, I can cast it as a list, and it'll say, okay, fine, I'll do all the reverse and put all the elements into a new list. But this does cause a memory duplication. 3 records here and 3 records there, 6 whole records. There's 3 extra integers floating in my memory. No big deal. But you could see that could add up. But so that's why that behavior is that way. That's why it gives back an iterator object rather than a list object, is to save memory in those cases. Just like with sorted though, I kind of recommend if you're coming at this and you're like, I understand what a mutable method is, I understand when to use sort and when to use sorted, do whatever you want. Like if you have some prior knowledge where these things are clear to you, then you can make whatever decision. If it isn't clear to you whether to use sorted or sort, or whether to use reverse or reversed. In either case, use the function version, because I think it's an easier tool to learn. I think it's a more forgiving tool to learn. Worst case is you might have some memory duplication here or there, and that, for now, that's not a big deal. The times when you start dealing with vast amounts of data and nuanced problems and programs, you're gonna, by that time, your skills are gonna be built to the point where you will understand when to use each one. So, okay, cool. Wow. We are running short on time, so I'm going to do a little triage here. I'm going to kind of just select some important ones. We'll go over these ones. If you want to go over, we'll go over these ones later. I'll try to mention them in the next class that I teach. Saturday, Tovio will be teaching, and then I believe I'm going to be teaching. I need to check the schedule. I believe I'm teaching either Monday or Tuesday, perhaps both. But Saturday, Tovio will be taking over. So I'll leave a couple for you to explore kind of on your own. You can look into those, count, enumerate parallel lists, unpacking. Okay, so we'll try to get through as many of these as possible. Enumerate. Enumerate, one of the most useful functions for lists and loops. Lists and loops go together. So let's say, okay, so there's a lot of problems like this. Actually, there's a problem like this in Learn that I was working with recently where it's like raise a number to the power of its index, right? So let's say we have list equals a list of numbers. And we'll say for I n list. Okay, src, and we'll call this ACC. Okay, so we'll say ACC list dot append. I'm going to call this ELE for element. LE. So for LE in list, for element in list. Oh, these are nums. I'll call them nums. We don't need to use element. For num in list, we can say accumulator list dot append num to the power of the index. Where is index? So I've got, okay, this is going to work for any problem that looks like this description. So you've got a problem where you're running a for loop through a list. You're traversing a list in a for loop, and you think inside that for loop, you think, oh, I need the index of every element. I need the index for this list, the indices for this list. If you ever find yourself thinking that, the answer is enumerate. Enumerate to the rescue. Now, enumerate is going to change our for loop a little bit. It's going to allow us to make two identifiers. Enumerate gives us back two things, and we can specify a name for both of them. The first thing it gives back is the index. The second thing it gives back is the element from the list that you passed to it. So this is going to work. Look at that. Let's see where I went wrong. Okay, source list. Okay, like I said, this is going to work. Okay, that actually worked. So you can see 4 to the 0 is 1, 5 to the 1 is 5, 3 to the 2 is 9, 8 to the 3 is 512, etc. So this is raising each number to the power of its index. I also have control over where this index starts. Sometimes you don't necessarily want to use it as an index. Maybe you want to use it as like a positional count of something. So if I wanted to start this at 1 instead, this is going to start index at 1 like that. You can see 4 is raised to 1 because we get 4 now. 5 is squared because we get 25. etc. Cool. Would it still work if you put for num idx? The order matters, yeah. So the answer is yes, it would work, but now num, the identifier num, is actually pointing at the value which represents the index, and the identifier index is actually pointing at the value that represents the number. This is a really what you might call a write time error, right? Which is a hard error to find because this is totally valid Python. Python's like, oh yeah, sure, I got no opinion about what you want to call those. Call them whatever you want. This is valid code, but it's not going to do what I expected it to do. So this is going to raise the index to the power of the value. But it's not clear that it's doing that because it looks like it's raising the value to the power of the index, because the way I have it written. So it's a great question because it's very important to remember. Enumerate gives you two things back, and it gives you the index and the element. The element doesn't have to, it could be a list of strings or a list of lists or a list of anything. It doesn't have to be numbers. But it gives you the index and then the element in that order. So that's important. In this case, if I'm starting it at 1, it's kind of wrong to call it the index because indices are 0 based always. So if I don't pass an argument for the index or the counter, it's going to assume to start at 0, which is convenient because that models indices. So I get started at 0 explicitly like this, or implicitly like this. Cool. I'm going to reckon that's all we got time for. So here's some ones. It's too bad we didn't get to count because count's a really useful one. Parallel lists and unpacking. So here's a few more. You can kind of go through these and play around with them. If you want to know more about any of these, you can always do. You can always use help. I'll give a quick demonstration on how to use help since we didn't get through everything if you want to kind of explore this on your own. So let's say you want to learn about count, parallel lists. This is the zip function. I'm going to put a dot in front of the ones. Unpacking is sort of a different concept. These are all functions. Okay. So if I want to use, if I want to get help on a method, I say help. We'll go in a terminal, and we're doing lists right now. So I'll say list dot, and then the method I want help on, we'll say count. And I do not put on the parentheses. Count is a method, so it would take parentheses when we actually use it. But I'll leave the parentheses off to pass it to help. And this will give me the internal documentation. So help's a very good function to learn about. If you don't ever, the way the help docs are written, it's a little dense. It takes some getting used to. Don't worry about understanding it all perfectly. Just use it as like a tool to kind of help give you a general idea about how it works. You might find something useful in here. So, and you might not, because sometimes it's a little bit dense. And then if I want help on a function, it's even easier. I just say help, and then the function name, so max, and no parentheses. Again, the function would take parentheses and an argument or whatever, but no parentheses when we're calling help. And then it's going to give me the help docs on max. And then to get out of that help window, hit the Q key, and that'll quit. It's Q for quit, kind of an old standard thing. So, all right, we will wrap up there. I'm going to stop the recording, and we will open up for